All right. Well, a pleasant good evening, everyone. Glad that you're here. We are in the middle of the week, just about, and this is the third day of classes. All right. We've covered a lot thus far, in my opinion. Some real good, important parts of this paper. Last night we did the transformation, and I haven't sent the video yet. I haven't sent the video to anyone yet. That's because I haven't uploaded it on YouTube. I plan to upload last night's video onto YouTube um, tonight. I hope that it works. And then I can send it to you all. I have the video, but it's not on YouTube yet. So I have to upload it to YouTube first. Then I can send the link to you all. So please bear with me. He's looking for that, yeah. So please bear with me for last night's video. Okay, so yeah, so last night we did this and we was discussing different transformations. We saw that there are different types of transformations. We saw that we can have, anyone can remember the types of transformations that we could have? Transformations.
Reflection.
Very good. Who said that? Again?
Reflect. Rotation and enlargement. Dilation.
Okay. So we learned that you could have reflection,
Rotation
rotation.
and enlargement.
There's something before this though. When we had translation,
Trans. Yes, sir.
and then finally it is
Enlargement.
enlargement. What's another word for enlargement?
Dilation.
Dilation. Very good. Dilation. Give me one moment. Let me open the door for this person. Sorry, so we learned about translation, reflection, rotation, and enlargement or dilation. What is translation? How do we define translation?
The moving of the image.
Very good. It's just a slide, okay, or just a movement, right? Slide or move. We saw that reflection is just a what?
Like the audience or like the mirror.
A flip. Very good. A flip or a mirror image, okay. And we saw also last night that rotation is just what?
Turn around and center.
Very good. A turn about a center. So when you turn in something about a center, so we have a center of rotation, and we turning it, we moving along a circle. So turning about a center. And then enlargement or dilation we saw was what?
Making the shape bigger or smaller.
Right, making the shape bigger or smaller. For center of enlargement, for enlargement rather, or for dilation, we need a center of enlargement. We need a scale factor, all right? And the scale factor is going to be how much we multiply by to get the other one. Okay, so that's what we dealt with last night. Um, we was not finished with that question, wasn't we? Right? We wasn't finished with that question yet.
We just finished with CPT.
No.
We didn't do translation.
Yeah, we did not do translation. We didn't do the last one. So we didn't do from A to E, didn't we? We didn't do that. We didn't do from A to E. And I think that's the last question that they asked us for. So they said figure A onto figure E. Okay. So just a bit recap. For question A, we saw that if we're moving the figure from figure A to figure B, so if we're moving it from figure A to figure B, we saw that that was a reflection in the line y equals to 0, right? We saw that if we're moving it from A to C, that's a rotation. How much degrees?
90.
90 degrees. Clockwise or
Clock,
anti-clockwise? Clockwise.
clockwise.
Yes. And what is the center of rotation?
Uh,
What's the center of rotation we saw yesterday? It start with O.
origin.
The origin.
Above,
The origin.
above the origin.
Yeah. So the center of rotation is the origin. So this shape, we move it 90 degrees clockwise, right? In this direction. And the center of rotation is the origin, or the or the the point in the middle right there. Okay.
This point in the center.
The point in the center, the point where the x and y axis is going to meet. Okay. That's what we call the origin. Okay. Then we saw that if we move from shape A to D, what is that?
Can you repeat that?
From A to D. That's that. That's what?
Enlargement.
That's enlargement. What's the scale factor? 2. The scale factor is 2. And what is the
With the same
go ahead.
origin.
Say it again.
The scale factor is 2, and with the center of the origin.
Center of enlargement is going to be the origin. Okay. And so that's what we saw. So this shape is getting bigger, right? A is getting bigger, and we basically twice the length of the sides. All right. Okay. So that's how we got moved from A to D. And finally, if we're moving from A to E, we can clearly see that that is simply a slide. All right. Let me show you clearly what I mean. Is that we move from A to E, right? That is simply a slide. You see, we just slide it over. So simply a slide, or it is just a moving. Just move it. Okay, slide or movement. Okay. If we want to be very specific, um, what we really did, I don't know if you could see it, but what we really did is we moved it over. So we slide it over here first, then we slide it above to reach to that point. You see that?
Yes, sir.
Yeah. All right. So that's how we're gonna basically describe the translation. We can describe the translation as, hey, how much did we move over? And then, hey, how much did we go up by? Okay. That's how we're gonna describe it. Okay, so let's do that. Now, in order to describe translation, we use vectors. So let me just make that clear. In order, sorry. In order.
Excuse me, Mr. Petit.
Yes, ma'am.
We're still going over the questions from last class, right?
What question?
No, I mean if you just was like going over what we did last class.
We moving on to the very last question. A to E.
I forget the question, please.
Yeah, let me give you it again. So they say describe completely the single transformation that maps figure A to E. So this is the last one that we didn't do. We know that from A to B is a reflection, from A to C is a rotation, from A to D is an enlargement. Now, from A to E, we found out that's a translation, but we have to describe that transformation using something interesting. Those are it's for 3 marks, so we have to say more than it's a translation. We have to give some more details. Let me know when I get
I
moving.
have to see the image.
Say it again.
I was saying if I could see the image, please.
No problem.
Kind of like a slide, an enlargement, because it looked like it get a little bigger.
It didn't get bigger.
So is that a slide?
That's what we just finished saying. You say, oh,
Oh, no, my wife.
we literally just that's what we literally just finished saying. All right, we literally just said that. Am I sharing? Can you see my screen sharing or what was happening?
Yes, yes. Bye bye. Bye bye.
Okay, so it is a slide. Now, remember, I said that we are going to describe it as a moving over to the left and then a pushing up. All right. So we're not gonna say, oh, we slide it diagonally here, right? No, we're not gonna do that. We're gonna say, hey, how much, how much did we move over to the left, and how much did we move up? All right. So that's the question. How much did we move over to the left, and how much did we move to the right up? Okay. Sorry, to the how much did we move to the left and how much did we go up by? All right.
-5.
-5. Okay. All right. I think you understand what's happening already. You're very good. All right. So let me allow this person to come in. All right. All right. So let's go back to the question now. So I'm going to take this image. I'm going to put that here. Let me crop it so that we won't have all those things here. So we just would be dealing with the figure itself.
And then, like,
Pardon?
I keep thinking you on Google because, like, had a picture up, had like
Yeah.
everything.
Yeah. It really camouflages itself well. Okay, for those who are just joining, thank you for coming. We are continuing the question we did last night. I was about to give you. Oh, what's this again? Sorry, I was about to give you some notes on this, and what I wanted to say is the following. In order to, I even forgot my train of thought, but that's let's finish it.
You was talking about that.
Yeah, I know I was about to say something about vectors, but so in order to perform the translation, not yeah, translation. we will use vectors. So by using vectors, we are going to describe fully, right, the transformation or the translation or the slide that occurred. So vectors is a very convenient way to describe, um, a translation or moving of something. Okay. So the way we're going to represent the vector is we're going to use open parentheses. So open parentheses like this. This will tell us. The top number is going to tell us the x value, and the bottom number is going to tell us the y value. So the top number tells us. The top number tells us. I didn't tell you all this before. I haven't given you all this notes before.
No, sir.
No, okay. So the top number x tells us how much we move to the left or to the right, and the bottom number, which is y, tells us how much we move up and down, right? So the top number is the x value that tells us how much we're moving to the left or to the right, and the bottom number, which is y, that tells us how much we're moving up or down. Okay, so it's important to keep that in mind. So let me know when it's okay to move this. So we're going to describe our translation using vectors. The top number is going to tell us how much we're moving over to the left or right. The bottom number is going to tell us how much we're moving to the up, how much we're moving up or down. All right. By using our vectors, we're going to describe fully the transformation, so the translation of the slide that occurred. All right. Okay. So by using these vectors, we are going to um, describe the transformation or the translation that occurred. Take a screenshot of it because we have to move. It's been on.
Can you repeat that?
Take a screenshot of it so we can.
Yeah, I got it. I only have to write what the bottom value is.
Okay. All right. So it's also important to note that when we have this like this, so if it's negative, negative means 2, the left. Negative means to the left. And what does positive means?
To the right.
Yeah. And positive means to the right. So negative means to the left and positive means to the right. Now, for the bottom, what do you think negative means?
Up. I mean down.
Down, yes. Negative. Good. Negative means downward movement. Positive means upward movement. Okay, so better than mine. So copy that down for me and let me know when you're ready for me to move it.
You can move.
Okay. Anyone else? Let me know if I can move it. Okay, so when we go to our graph, let's say look at this point. You only need 1 point to tell us, because 1 point will tell us it all. How much did we move over to the left? It's gonna be 1, 2, 3, 4,
5 times.
5, 6, 7. We move 7 to the right. How much did yeah, we move 7 to the left. So if we construct our vector, right? If we construct our vector, we're gonna have positive 7 or negative 7. Remember, we moved to the left. So positive 7 or negative 7.
Negative. Negative 7.
Very good. Negative 7. And then now we're moving right upwards, right? So it's not right upwards, my bad. We're moving upwards. So it's gonna be 1, 2, 3, 4,
8.
5, 6,
48.
7. I get 7. How you get 8? You don't count the number you don't count the one that you start on. So 1, 2,
Oh, that's right.
3, 4, 5, 6, 7. So that's gonna be what? Positive 7, right?
Yes, sir.
Good. So how would we write that? So how are we gonna write our answer for that particular question? We're gonna say, let me know when you're ready for me to move it. Can I move it? Say it again.
I know what we just said.
What you could say. So let's get back.
This is a slide. You can say this is a slide.
Okay, that's close enough. Let me get the question for us first. Fantasia. All right, welcome, Miss Ingram. Fantasia, that's you. Miss Ingram, that's you? I would say an uninvited guest. Let me see. Hey, Conrad.
Good night.
Hey, how you doing?
Are you good?
Okay. Kennedy, that's you? Oh, that's Kennedy. All right.
I'm interested.
She said, yeah.
But she got on mute.
Kennedy never be on mute. Kennedy.
Say after on this joint.
She was talk already.
Yeah, Kennedy usually talks.
Mr. Boutique government people and being here for the night. Yeah, I know.
Fine, Kennedy. Kennedy with a den dog.
They always come in with that great
Okay. All right, so
that was fun.
Fantasia usually speaks too. Immediately, she don't take long. Okay, so we're moving it figure A to figure E. So what is how would we describe the translation? Oh, I already have that there. So we'd say this is a translation. This is a translation through the vector. Through the vector. What's our vector?
-7/7.
Yeah, -7/7. So this is a translation through the vector -7/7.
Mr. Batik, like
Yes,
how
ma'am.
I thought this is a slide through the vector -7/7. Would that still be right?
Use the word translation.
Okay, so I can change it.
So it's a translation to the vector -7/7. So that's the correct answer for this one. Like I say, math is easy. Don't make it hard. Let me know when you're ready. Let me know when you're ready. Can I move it?
Right now, Mr. Boutique.
Okay.
I don't write it.
You already have it? Okay, good. All right.
Yes, sir.
All right. So it's a translation to the vector negative 7, 7. And when we say a translation is a slide or it is a it is a move. All right. Hello, Mr. Brathwaite. That's you, Joseph? Brathwaite, that's you? Brath
Nope, one little yes, nine.
Yeah, I know. It's crazy.
They really are nothing.
Yep, yes, Miss Reckley. All right. Yes, ma'am.
And I think you have to change the length next.
I mean we only have one more week of classes, so I'm like, don't make no sense. Just leave it until next year. So we can roll with the punches for this lap, and then come next year, I'll change it every class. But I don't want to complicate things, seeing that we coming down to the end. Okay, so let's move on. Let's finish up the rest of these things. So this is going to be all right. So we want to simplify this particular expression. It says 3 plus 7 open bracket 5 minus 2b plus 4b. So I'm going to give you a moment, try it on your own, and then we could do it. So 60 seconds to try it on your own, and then let me know what you get, and then we can work it. Okay, so what do we get? Anyone? Oh, we're still working. Hello? Can you hear me?
Yes, I still working it out.
Okay, still working. All right. So I'll begin and you'll catch me. Hopefully you finish before me. All right, so that's how we do it. We say 3 plus 7 open bracket 5 minus 2b plus 4b. All right, and so what happens here is we see, the first thing we're going to do is we're going to multiply. We're going to multiply this 7 by this 5. And so it's going to be equal to 3 plus, what is 7 times 5?
35.
35, very good. Next we see 7 multiplied by negative 2b. 7 times 2 is going to be 14. Yeah, so it's going to be negative 14b. What's your answer? What's your answer?
38 minus 18b.
38 minus 18b. Okay, that's what she got. So let's see. So next, you have 7 times 5, which is 35. 7 times 2, which is 14b, plus 4b is going to be equal to, what is 30? What is 3 plus 35? 38. But what is, watch this now, what is negative 14 plus 4?
Negative 18.
No, sir.
What?
Negative 10. 10.
Negative 10.
Negative 10.
Negative 10b.
I changed it to 10b.
Oh, I see my mistake.
Yeah. Remember, you owed 14, you have 4. So pay them back the $4 you owe them. So you left with $10 that you still owe them. So the answer is 38 minus 10b. Who's just trying to join at the moment? Nope. $38 minus 10b. So let's do another one like this, shall we?
Yes.
Do another one like this. Don't get it wrong now.
They trying so hard.
Very hard. Okay, so let's say we have 4 plus 8, open bracket, 6 minus 3a plus 2a. So what is that answer? So work it out. 30 seconds.
$52 minus $22.
All right, we have an answer already. Okay. Say it again. 52 minus 22a.
Yes, sir.
All right. So let's see. So it's going to be equal to 4 plus, remember, 8 times 6 is going to be what? 8 times 6 is definitely 48.
I agree with her.
You agree with her? Next we have 8 times negative 3. That's going to be 24. Sorry, let's use red. minus 24a plus 2a. Now, now we're going to add, so what is 4 plus 48? That's going to be what? 52?
52.
Now, negative 24 plus 2 is what?
22A.
Negative 22a. Very good. So this was correct. That's what as Miss Gardner said. Very good. Very good. Shall we do one more? Or that's enough?
Let's do one more.
Do one more? Okay. Okay, let's make this one interesting. So it's gonna be a little bit more involved. So let's do it. So be careful now. I warn you. All right, try that. Uh-oh, this is difficult. Try that. 8 plus 4, open bracket 2 minus 3c, plus 9 minus 2, open bracket 8 minus 7c, close bracket. Gotta be very careful with your letters with this one. We're done? Anyone done yet?
Mr. Bate,
Yes, sir. I read it. I ain't going nowhere.
why don't you do one?
Oh, I read it. They just take long to answer it. I'm ready to do it. Okay, so let's do it. So it's gonna be equal to. Notice that I always have my equal signs. All right. So this is gonna be 8 plus 4 times 2. What is 4 times 2? 4 times 2 is
8.
definitely 8. Yeah. 4 times 3 is gonna be what? 4 times negative 3c. That's gonna be what? Minus 12c. We bring down the 9. That's gonna be plus 9. And then we say negative 2 times 8. What is negative 2 times 8? That's gonna be what? Negative 16. And -2 times -7 is going to be positive 14c. And so this equals 2. So now that I've simplified for you, try simplifying now. Come read back. All right. So when we simplify it, remember we got to put all the c's together and all the numbers together.
I got 9 minus 2C.
9 minus 2c. 9c. Is that you?
No, that's okay.
No,
I get 9 plus 2C.
Nancy, is that you?
Genau.
Okay, good.
I get 9 plus 2C, Mr. Petit.
You get 9 plus 2c, and someone get 9 minus 2c. Okay.
My answer right.
Say your answer. All right, we'll see. All right, so let's group all the numbers together. First, we could do, before we even group the numbers together, let's deal with 8 plus 8. 8 plus 8 is going to be what? 16. And we keep this 12c, right? So negative 12c, that's fine. What is 9 plus what is 9 minus 16? What is 9 minus 16?
7.
7? Yeah, that's right. No, not positive 7.
Negative 7.
Negative 7. Good. Plus 14c. Good. Now we could group all the like terms together. So the 16 and the 7 goes together. So it's going to be 16 minus 7. Then the 12c, negative 12c, and the 14c goes together. So it's going to be negative 12c plus 14c. So it's going to be equal to, what is 16 minus 7?
9.
9. And what is negative 12c plus 14c?
Positive 2C.
Positive 2c. And so that's correct. So it's 9
So I
plus
was right.
9 plus 2c. If you said that, then you were correct. Nine plus 2c. Right, let me know when you finish copying that down.
I done.
I'm done.
Okay. All right, that's good.
We doing one more?
No, that's enough. That's enough. We did like 3 of these already. Okay, so next up. I shouldn't be expecting anyone. That's an old picture. You know how long Miss Kelisha Sanders ain't come to this class?
My name is Bell Sanders, right?
But my thing is, she ain't come to this class in a decent minute. Let me. You know to do with the battery. Just switch it. Okay. Okay, so next up is going to be, let's do this one. It's going to be 3a over 5 plus a over 6. And we want to simplify these things. So try it. And let me know what you get. 3a over 5 plus a over 6.
This is a pure guess.
A pure guess.
1/3, 1a over 3.
1a over 3?
1a, yeah, over
All right.
3.
1a over 3. Okay, thank you so much for the response. Anyone else?
1 minute plus 14.
Yeah, I was waiting on you to respond, Nancy. I was saying where my Nancy is. You know where I am from? I am from Keanu.
I changing that, okay? I coming back. I changing.
You changing that? Okay, so this is an answer that is subject to change.
Precipitate, I got 23 a over 30.
Would you say 20?
23 a over 30.
Over
I got
30?
that
I
too.
got that too. I got that too. I revised. I got that too.
You got that
I made
too?
a mistake. I got that too.
Okay, all right. Nancy, I don't know. Apparently, when you get it, everybody get it at the same time.
No, I was doing it over. I saw my
That's so funny. Nancy, you need to start giving your answer earlier so that everybody could follow suit. But I trust you. I trust that y'all did it independently. Very good. Um, so the first step here is we want to find the LCM of 5 and 6. So first let's have the multiples of 5. It's going to be 5, 10, 15, 20, 25, 30, 35. Next, let's in the multiple of 6. We get 6, 12, 18, 24, 30, 36. So clearly, the lowest common multiple here is 30. So thus, the LCM of 5 and 6 is 30. So that's important. So now that we have our LCM, the next thing that we're going to do is we're going to construct equivalent fractions for 3a over 5 and a over 6, such that the bottom number, the denominator, is 30. Again, we're going to construct equivalent fractions for this fraction and for this fraction, such that the bottom number, the denominator, is 30. And so let's do that. So again, we are going to find equivalent fraction for 3a over 5. We need equivalent fraction for a over 6. And we need to have an equivalent fraction such that the denominator, we already know, is going to be 30. And so the natural question is, how do we move from 5 to 30? What must we do?
By 6.
Multiply by 6. And how do we move? And obviously, whatever we do to the bottom, we must do to the top. So we're going to multiply that by 6 as well. So 3 times 6 is definitely 18. So we have 18a. Next, we must find an equivalent fraction for a over 6 such that its denominator is 30. And so the natural question is, how do we move from 6 rather, to 30?
5.
We must multiply by 5. Very good. Whatever we do to the bottom, we must do to the top. So it's going to be multiplied by 5 until 5 times a is definitely 5a. And so what we're going to do now is we're going to go back to our question, which is 3a over 5 plus a over 6. And we know that's going to be equal to, the equivalent fraction for 3a is going to be 18a over 30. And the equivalent fraction for a over 6 is 5a over 30. And so adding them, we keep the denominator as 30. And so it's going to be 18a plus 5a. And 18a plus 5a as 8, 9, 10, 11, 12, 13. Sorry, 18 rather. 18, 19, 20, 21, 22, 23. So that's 23a over 30. And so for all those who got that, that's Nancy, Miss Gardner, and Miss Cooper. Very good.
We can do next one. Please.
I'll do the next one, no problem. Let me know when we are done with this. Can I move it?
Yes, sir.
Okay. Okay, so let's say that 7, this is 4b plus b over 20
Miss Ortega wrote something at the bottom.
Pardon? At the bottom?
Never mind.
That's all I had.
Oh, no, never mind. Sorry.
Yeah. Oh, yeah, I haven't written it yet. Okay, so try that one. This one should also be simple as well. Try that. Let me know what you all get.
B over 28.
Okay. With confidence. 17b over 28. All right. Anyone else?
I agree with Scott.
All right, you agree with this, God? No. Anyone else? They got 17b over 28. So 17b over 28. All right, so the first thing we're going to do is we're going to find the LCM. And so the LCM of 7 and 28 is definitely what?
28.
28. We have 7, 14, 21, 28 times 5 is 35. And we have 28. Immediately, that's the case. If we want to continue, we could do 56 and so on. But we could stop right there. So we know that this is immediately going to be 28. So therefore,
I got that too, Mr. Latif. 17 be over 28.
okay, 17b over 20. Okay, Ms. Cooper. So the LCM, thus the lowest common multiple of 7 and 28 is going to be equal to 28. And so seeing that we know that we need to construct two equivalent fractions such that the denominator of both of them is 28. And so we're going to do that. So the first one is going to be 4b over 7. The next one is going to be b over 28. And we know for sure that our denominator must be 28 in both cases. So the natural question is, how do we move from 7 to 28? That's going to be what?
4.
Multiplied by 4. How do we move from 4b to 20? How do we move from, sorry, whatever we do to the bottom, we do to the top. So multiplied by 4, that's going to be 16b. Here, how do we move from 28 to 28? By multiplication, we just multiply by 1.
1.
Definitely, whatever we do to the bottom, we must do to the top. So this is 1b. And so we have here is we have 4b over 7 plus b over 28. And it's going to be equal to 28 over 16b plus 1b over 28. It's going to be equal to 16b plus 1b all over 28. It's going to be equal to 17 rather, b over 28. So that's how we do that one. Any questions for me?
No, sir.
Okay. Okay, can I move it?
Yes, sir.
Okay. All right, so let's move forward. All right, so that's done. So that's it. We did the factorization thing yesterday. How to factorize it. We did the simplification today, and we did this again also today. Yeah. This was on Monday, right? That we spent the entire night doing this question. So if you
Yes, sir.
yeah, that was rough. So make sure to look at this question, and then 16 that was yesterday, and some bit parts of the day. Nancy, make sure look at the video because we did the transformation. The last question D, as we began the night with. So look at the video for that one.
Okay.
Okay, now let's move to this question. All right, this one should carry us for the rest of the night. Okay, so it says here, let me grab the question. What do they want? They want here. He wants to calculate the length of BC. So let's do that first. Okay, so here it says the diagram shows the support bracket for a restaurant sign. AB equals 60 centimeters. So that's this thing right there from A to B. That's 60 degrees. Sorry, that's 60 centimeters. All right. AC is 109 centimeters. So that's this point to this point. That entire length is 109 centimeters. And the angle BAD is equal to 41, which means we're talking about the one in the middle, the angle in the middle. So when you have the one in the middle, when we have it set up like this, we are referring to the one in the middle as the angle that we're talking about. So, and when we have BAD, that just tells you which triangle we're talking about. So BAD, we're referring to this particular triangle right there, right? And so we're actually referring to this particular angle right there in the middle right there. So this one is what is 41 centimeters. Sorry, 41 degrees. Okay. And so that's 41 degrees. And what they want us to do is they want us to figure out the length of BC. The length of BC. Okay, now BC is going to be, we're going to start from, obviously we're going to start from B, and we're going to go all the way to C. So BC, the length BC is going to be the length of this entire thing right there. Okay, this entire length. So this very line right there is the length BC. Okay, from that point to that point. That's the length BC. So that's the length that we're trying to find. And so we're going to use, anyone know what we're going to use to figure out that length? No, not length times width. Notice, right? Notice carefully. You got to be paying attention now. Notice the triangle that I'm drawing in blue. Okay, notice the triangle I'm drawing in blue. All right, you see that big triangle, right? That I'm drawing in blue.
Yes, sir.
Good. I am going to take that triangle and I'm going to put it out here and have it like so. So that's going to be, the side is going to be how much? 60 centimeters. This one is 109. This one is B. This one is C. And this one is A. So the side that we're looking for is this. We don't know what that is. So since we don't know what it is, we're going to call it, let's give it a letter. Let's give it a name. So we don't know what the length is, but let's give it a name to represent. Let's give it a name to represent its value. So let's say that length is, say, let's call it B, small b. Okay.
Are we using the a squared plus b squared plus c squared formula?
Yes, ma'am. And what is that called? Pythagoras theorem.
I forgot the name. Sorry.
That's fine. So let's do it. So to find or to determine the length of BC, we will use Pythagoras theorem. Now Pythagoras theorem, now we always use Pythagoras theorem when we have, when we are given, when we are given, I do. Oh my goodness. Oh, sorry. I messed that. Okay, so I gotta rewrite it. Can someone tell me what I had before?
You have to determine the length of BC. We will use Pythagoras theorem. Now we will always use Pythagoras and then stop.
To determine the length, sorry.
To determine the length of BC, we will use the Pythagoras theorem.
Pythagoras theorem.
And then you say, now we always use the P word and then you stop.
Yeah, so now you'll always use Pythagoras theorem when we have, or when we are given the lengths of two sides of the triangle of a right angle triangle. It has to be a right angle triangle. And we want to solve, and we want to find the missing side. So we always use Pythagoras theorem when we are given the lengths of two sides, when we have, or when we know that it is a right angle triangle, and when we're trying to find the length of a missing side. So use Pythagoras theorem when you are missing one side, but you have the lengths of two sides, and it is a right angle triangle. Again, we use Pythagoras theorem when we are given the lengths of two sides, and we have to find the missing side, and we have a right angle triangle. Is that clear?
Yes, sir. So it only could be a right angle?
It only could work with right angle triangle. That's Pythagoras theorem. Only works with right angle triangle.
Okay.
Okay. So look at our question. Here we are given the length of two sides. What's the length of this side?
60.
Good. What's the length of the other side?
109.
109. And we have defined our missing side, right?
Okay, I
Yes, ma'am.
have a question.
Yes, ma'am.
Okay, I had to find out like when you draw it again that if we was using the Pythagoras theorem methods. I was wondering how do you determine when you have it all together? Because next it's together. So how would you like determine which formula you're using, or you just have something good a good eye to see?
No, I just gave you the criteria. Notice that we were given two sides, right? So we were given this length and we were given this length. Okay? And we have defined out the length of BC. So that tells you right there, that's Pythagoras theorem, because remember, Pythagoras theorem is when what? You are given two sides and you're trying to find the length of the last one. And it is a right angle triangle because it have the box thing. So that's how we know. Is that clear?
Yes, sir.
Okay. You sure?
I don't know what how to figure it out.
It ain't that deep. It really ain't that deep. All that's happening is that we have like we given one side, we given the next side, we trying to find this length. That's it. So do you know automatically that's Pythagoras theorem? Because you are given the length of two sides, and the thing is a right angle triangle. We're trying to find the length of a missing one. Does that help at all?
Yes, sir. It'll register eventually.
Yeah, I hope it does. Before May 31st. All right. Okay, good. So we're gonna call the length of this side that we're trying to find B. We're gonna call it B. Okay, that's what we call it. So now let the length BC be equal to B. Then we determine the value of B in the following way. So we say A squared, we say A squared plus B squared equals to C squared. And so we are going to send the A squared over. So we're going to be left with B squared equals to C squared minus A squared. Next, we're going to take the square root of both sides. So it's going to be c squared minus a squared. Next, we know that a square root cancels the square. So we are left with b equals to the square root of c squared minus a squared. So that's what b is, right? That's what b is. That's the length that we're trying to find. That's what b is. So we have the formula for b. Now we're gonna use it to figure out what the actual value of b is. So let me know when I can move this.
Can you explain how you cancel out the two, the p squared, the two on the p squared, please?
Okay, that's just a rule that you know, right? Whenever you have a number raised to a power and you take the square root of it, they cancel out each other. That's just the rule.
Okay.
Yeah. And so b is going to be equal to the, the square root of c squared minus a squared. And so let's use that formula. So b equals, are we done with that slide? Or I need to state that some more,
That's how we done.
Okay. All right, so remember our triangle now. If we go back to our triangle, this was b. This was how much? 60. And this was 10 what? 10 what? 109.
109.
So
109.
so if this is b, then we're gonna call this one c, and then we're gonna call this one a. And so that's substituted. So b is gonna be equal to the square root of, what is c? C is 109, so it's gonna be 109 squared minus, sorry,
Minus 60 squared.
minus 60 squared. Very good. B is going to be equal to, what is 109 squared?
Oh, 218.
218? That can't be right.
11881.
Yes, that's true. So 11881, 11,881 minus, what is 60 squared?
3600.
3,600. So B is going to be equal to the square root of, what is 11881 minus 3600?
8281.
Now let's take the square root of that. What do we get?
91.
91. So B is 91. So B therefore equals to 91. So the length of this missing side is 91. Any questions for me?
No, that's okay. Can you go back 2 slides, please? Keep going. Um, you keep going.
Okay, one moment. One moment. This thing is gonna shut off. All right, can you all hear me? Can you all hear me?
Yes, so we hear you.
Okay, good. So you was telling me to go back to something, Miss Miss Nancy.
Yes, so the slide where you had the question,
Oh, where had the
I
question?
wanted to draw the
Okay.
angle 5.
Okay. Can you move it? Let me know.
I can't see your screen, by the way.
You can't see my screen?
No.
No.
I can't see your screen. Yes, can I? Is it petite?
It
Okay,
didn't
now
see.
I can see.
You can see it. Okay.
But we can see it now.
You can see the question now, Miss Nancy.
Yes, sir. Thank you.
Okay. All right, so that's how we figure out that the length BC is 90 degrees. Sorry, no, not 90 degrees, 91 centimeters.
91.
Okay. Can you all see what I wrote just now?
Yes, sir.
Okay. So 91 centimeters. All right, so that's that question. Let's move on to the next one. So now we want angle C. We want to determine angle C. So what is angle C?
Alrighty, Mike.
Whose mic is that? That's from Scoopy.
I was Conrad.
Oh, okay.
My name famous Steve.
All right, so angle C. Okay, so angle C is going to be this length, this angle right now. All right. Um, can you all see what I labeled? I want to know if you all see what I doing.
Yes, so email that right there.
Yeah. Say it again.
You can see it.
All right. So we want angle C.
You can see.
All right. So how would we figure out what is the length of angle C? Or not the length, but the size of angle C. Anyone? And let me just ask the question: how would we figure out angle C? Anyone have any ideas?
I'm just guessing, so I don't know this right.
Yes.
You get me?
I get you.
So this is a triangle.
Yeah.
It's a triangle, so this equals to 180. So I guess you add 41 to the 90 degrees and subtract it from 180, but that might be wrong.
Maybe wrong. Anyone agree with Miss Rackley?
How makes sense to mine, but I don't know.
Say it again.
Um, how made more sense to mine, but I don't know.
Well, how would you do it?
I'm, honestly, I am taking. Okay, we already know. I was trying to figure out. Okay, so I was thinking. I was thinking if 8 up there is 41, and then it's an angle out. So 180, that's regular. Not 180. Would be in the inside, so that would be um the blank angle next to A would be 180 minus 41, and then I'll have that. And I could basically try to figure out A and B and subtract it.
I see what you're saying.
You know where the
I
difference
see what you're saying.
more sense. Yeah,
Um, so I like the way y'all minds are. I didn't even see that. You all are saying that, hey, okay, if this is 41, if this is 41, and we know that all angles in a triangle add up to 180, right? Then we are able to find what C is. Now, that's a good try, but unfortunately that's incorrect. And let me tell you why that's wrong. if you look carefully what 41 is talking about, 41 is talking about this length right here, this angle. Okay, just this one, the angle that is a part of the red triangle. So just this part is 41. Okay, not the whole thing is 41. Not the red and the blue, just the red. Can you all see that?
I was looking at that afterwards.
Yeah.
Like, I don't know that.
So now what you suggested would be right, would be good if we was trying to find D, right? Because then we know that 41 plus 90 plus this yellow one, right, is going to be equal to 180. So that would work if we was trying to find D your way. But we're not trying to find D, so that way wouldn't work. The thing is, we dealing with the big triangle, all right? We dealing with the big triangle, the one that's on the outside, right? We dealing with this, and say it again. What you mean?
I'm even looking for the long angle. I see bubble in the other one.
Oh, what I was saying is, I was telling her that if she wanted to find this one, angle D, then she could have used the way that she talked about. Because 41 plus 90 plus this yellow one is going to be equal to 180. Okay? You understand that? So for this first triangle, for the small one, that would have worked. But the problem is we're looking at angle C. And angle C is not a part of the small triangle. Angle C is a part of the big triangle, which is this. Okay? So angle C is a part of the big triangle. So we can't use that one. So what we could do, let's take that big triangle out again. And let's isolate it and see what we have. So we know that this one is 90. We know this one is 91. This is 60. This is 109. And we know that this is 90 degrees. That's the only thing that we know about this angle. We don't know nothing else about this angle. Sorry, this triangle. That's the only thing we know about it. And so the way that we're gonna figure this out, can you all see what I'm writing? Please let me know.
Yes, sir.
Okay. So in order to be able to deal with this question, we're gonna use something called the sine rule. The sine rule. Anyone ever learned about the sine rule before? No? The sine rule. That's what we're gonna use to be able to solve this. The sine rule. So for the sine rule, we are gonna call well, they already tell us what it is. This is A, so this we're gonna call this one A. This is B, so we're gonna call this one B. And this is C, so we're gonna call this one C. Say it again.
I can't see a screen.
You can see my screen?
The screen just froze.
It froze? Okay.
I just
Always with in and out. All right. Are we good now?
Yes, sir.
Okay. So we're gonna use the sign rule. Now the sign rule is the following. So let me just write down the notes here. So for this question, to determine the size of angle C, we will use the sine rule. Now the sine rule is the following. The sine rule states, let me just write that. The sine rule states the following. Oh, guess what? Turns out that was Kennedy. The sine rule states the following. Are you all there? Can you see what I'm writing?
Yes, sir.
So this is what the sine rule says. The sine rule says sine of capital A over small a is gonna be equal to sine of capital B all over small b. It's gonna be equal to sine of capital C all over small c. So that is the sine rule.
This is trigonometry.
Yeah, that's trigonometry. So if we have a triangle like so, if we have a triangle, no, it's not hard. It's not hard. It's just you just gotta remember some stuff, but it's not hard. So if we have a triangle, go ahead.
True, that's why. I said I forgot how to do trigonometry.
Okay.
That's why I said it.
Okay. So if we call this side small c, then this would be, so if we call that one capital C, this would be small c. If we call this one, this side, sorry, if we call this angle capital A, this is going to be small a, this side is going to be small a. And if we call this angle here capital B, then this side is going to be small b. So let me help you understand what's happening here. Let me do it again. Again, if we have a triangle, if we call this one C, this is going to be, no, let me do it side by side. So let's split the screen. If we have a triangle, right here,
I
if
think
we
you
call,
froze again.
say it again, it froze. Okay, let me know. Let me know. Let me know if you could see it now. Okay,
Mr. Petit,
go ahead.
Mr. Petit.
Go ahead.
This will be doing. You see trigonometry like this on the BJC paper.
Bgcse? You don't even find it on the Bgcse. That's for my Bgcse students. But
So
you're gonna encounter it anyway. So when you reach in grade 10, you can
can you
find.
repeat that?
You're going to encounter it anyway. Yeah.
Okay.
Yeah, you're gonna have to learn it anyway. Anyway, you put it. So might as well get a head start on it.
Okay.
Yeah. Okay, so the idea here is that if this is capital C, this is small c. If this is capital B, this is small b. If this is capital A, this is small a. So if we go to our triangle that we have, we know that this here is 91. This here is 109. This here is 60. This here is 90 degrees because that's a 90-degree angle. And um, we saw that this one was angled C. So if that is capital C, then 60 is going to be small c. If this one is 90, that's A, then this one is going to be small a. All right, so we have everything that we need. We know that we have sine C, capital C equals to, sorry, not sine C, sine A rather. Sine capital A divided by A is going to be equal to sine capital C divided by C. We know that sine A, what is capital A? What is capital A?
90.
90, very good. Capital A is 90 degrees. Divided by, what is small a?
109.
109. Um, what is small, what is small c?
91.
No, small c is going to be this. So small c is 60.
60.
Yeah. And then what is sine c? Well, c is the angle that we don't know yet. So we can't put none for this one. We don't know what that is yet. So the next thing we're going to do here is we're going to cross multiply. So 109 times sine c times 60 times sine 90. So when we cross multiply, let me know when I can move it. Let me know when I can move it, okay? Hello, is anyone now?
Yes, sir. We here. We here.
I was saying, let me know when I can move it. Say it again.
Yes, sir. Yes, sir.
Okay, we can move. I could barely hear whoever is speaking as I could barely hear you. Okay, so
We done, Mr. Petit. We done.
I could hear you definitely. Definitely, I could hear you, Miss Cooper. I don't have a problem hearing you. Yeah, you is the problem. I could barely hear you.
Hello?
I could hear you. I could hear you, but it's slow. Oh, 1 minute, 60 seconds. So all we did was, uh, all we did was, no. Next thing we do is we take 60. Sorry, we take 60 and we multiply it by sine of 90. So 60 multiplied by sine of 90. It's going to be equal to 109 multiplied by sine c. Okay. Now, what is sine of 90? And we can put it in that calculator. Sine of 90. If you put in your calculator, sine of 90 is supposed to be 1. So it's going to be multiplied by 1 equals to 109 times, yeah, it's 1, times sine c. What is 60 times 1? 60 times 1 is 60 is equal to 109 sine c. Now we could switch the equation around so that we get sine c is equal to, 109 sine c is equal to 60. Now we want to divide both sides by 109. These two going to cancel. Divide both sides by 109. So we get that sine c is equal to 60 over 109. Now we're going to take the sine inverse of both sides. So it's going to be sine inverse of this. Sorry, let me do it on another line. So we're going to do sine inverse of sine c. And that's going to be equal to sine inverse of 60 divided by 9 divided by 109. And so therefore we know that sine inverse and sine going to cancel out each other. So we left with c equals to sine inverse of 60 divided by 109. And so c is going to be equal to, what is sine inverse of 60 over 109? Sorry, I left my calculator in the room. I come right back. What you get?
33.39.
Yeah, 33.40.
I got that too.
Yeah, 33.40.
So we rounded.
Yeah, we rounded.
We always rounded.
I think they say the 2 decimal places, right? But I round the 2 decimal places. And so the angle is, so angle C is going to be 33.40 degrees. Okay. Any questions for me? No questions, so we understand this perfectly. Okay.
The only dumb. The only dumb.
I have
Uh-huh.
so the third question, okay? use me, I can say right.
Yeah.
You calculate this. We didn't calculate all this. On calculate. I boss.
Say it again.
From give me from how do you calculate this on the calculator without doing all that?
Without doing all that, this is the working.
Like on the cal. I know it's the working, but I never went that deep into it in class or anything.
I can barely hear you, Nancy.
We have to do this again class. We have to do another one of these next class.
Oh, okay.
Okay.
With God to say we have to do another.
Never mind. I just find out.
Voice note me because I could barely hear you.
At the end, you run. At the end, you just run through that last. At the end, we have to do this again.
Okay, we have to do this again. All right, it is deserving of several other videos. It is really. Um, we have to do several more. So you could really get it. I don't think one example is gonna give it justice. Um, so yes, we have to do other ones. It is a lot. Even when I did it in class with my students, we had to do it at different times. So I know it is a lot. It is a lot, especially if it's your first time seeing these stuff. You'd be like, what these stuff is, what these stuff means. I know. But I just wanted to give you an introduction to it so you could feel and see what you're up against. Um, but we don't have enough time for me to do it all over again and really milk it. But I just wanted to give you a feel for what you're up against and give you a little introduction of what's happening. Okay. We have to tackle this question, a similar question again. You have to become familiar with doing these though. They always come. One thing, these questions always come. So you have to become familiar with sign rule. Even if you want me to send you some exercises on sign rule, I could do that.
Yes.
Yeah.
Will be spelling from it?
Okay. All right. So we know that the angle is C. The angle C is 33. We're already at 8:04. How? How? So we definitely are around out of time. So we on English time now. So when we come back again, we're gonna do the same problem or do another problem.
And finish off this one next.
Finish off this one. Okay. All right, then let's do that. We'll do that. I'll even go over back um, this particular question from the beginning, and then we'll finish it. All right, so we get a good overview. For those persons who are not in grade 10 yet, consider yourselves lucky or blessed because you're getting a good head start. Getting a good head start. So that's good. All right. So any questions before I move on to language? No? Okay. So if you do not need to take the BJC or Bgcse language exam, you are free to leave. But if you are, then you would have to stay for our English class. All right. So we're gonna transition over, and we're gonna finish up our fallacies. So we're gonna go back to something that is easy for the mind, because that sign rule was something else. So let's continue with our fallacies. The last type of fallacies we did was what? What type of fallacy? What was the name of it? Can you all hear me? Hello, can you all hear me?
Yes, sir.
Okay.
Yes, sir.
Yeah, I was asking what's the last type of fallacy that we did? Hello? Are we here?
Yes, sir.
Yes. I was saying, what is the last type of fallacy that we did together? We don't know? Okay. Anyone else? What was the last fallacy we did? What? We don't know?
I wasn't here Monday.
It was in on Monday. Nancy, what was the last fallacy we did?
Someone said it in the chat.
Someone said it? Someone said it? No? Okay, so let me help you out. The last type of fallacy we... Oh, in the chat. Okay. Let me see. Who was that? Abigail? Oh, McQuell. Very good, McQuell. So the last type of fallacy we did was non sequitur. What's her name? Nancy. Nancy Lefty. She's supposed to know that. Okay. Oh, okay. I could barely hear you. I don't know. Y'all can hear her? I can't hear you, no, Nancy. You're very low. Please. Try speaking now.
Can everybody hear me now?
Okay, I have you on speaker. Good. Would you say, what was your excuse again?
It's not an excuse. I said, I can pronounce it, so
Oh, you're,
don't bother.
you're looking for the answer.
No, I can pronounce the word.
Oh, oh, okay. You didn't want to embarrass yourself. That's funny. All right. So the next one that we'll be doing is the slippery slope fallacy. Right, slippery slope fallacy. Now,
Yes.
say it again.
Yes, screen freeze.
My screen froze. Okay. Well, listen carefully to what I'm saying until it comes back. Slippery slope is this is a fallacy where it's similar to non sequitur. All right, it's similar. Am I still on? Okay, good. It's a fallacy that's similar to non sequitur. Let me Okay, can you all hear me? Can you all hear me?
Yes, sir.
Okay, so for can you see the screen?
No, we can't see screen.
Can I see the screen?
Yes, sir.
Okay.
I can't see it.
Okay, give it a while then. So for slippery slope, that's when it's very similar to non sequitur. Slippery slope um is when the same thing like non sequitur, whereby the premise does not follow with the conclusion. The only thing is that the slippery slope is worse than the non sequitur, right? And we're going to discuss that right now. So, um, and the thing about the slippery slope is that it has a characteristic whereby it has multiple steps to it. Okay, that's why it's called slippery slope. Like, because your first point it was off, then that makes all the other points that you say after that off as well and deeper off, right? So what I mean is a slippery slope is an assumption that a chain of events will lead.
Miss Petit, I can't see a screen.
You can't see my screen at all? Okay. Can you hear my voice though?
Yes, sir, but I know what
Okay.
to write.
Okay. I'm gonna put in the chat. So it's an assumption that a chain of events will lead to some dire consequence for which there is no, or for which there's insufficient evidence. So now it is similar to non sequitur, but the conclusion requires a greater leap in logic to connect the premise with the conclusion, or to the conclusion. So, yes, ma'am.
Screen on.
Yeah, it's
I
on.
can't see me though.
Yeah, I'm gonna post it in the chat though. Okay, so I posted in the chat. So it's an assumption that a chain of events will lead to some dire consequence for which there's insufficient evidence, similar to non sequitur, but the conclusion requires a greater leap in logic to the premise to a greater leap in logic to connect, to connect, to connect the premise to the conclusion. Can you all see that in the chat?
Yes, sir. I read it.
Okay. So an example, right? An example would be, um, what would be the consequence if the government does not control immigration effectively? What would you say? What would be the result if the government does not control immigration properly?
There will be chaos.
There'll be chaos.
They will keep coming and coming and won't stop.
They'll keep coming and coming and won't stop. That's what you're saying. Someone say there'll be chaos. Um. Anyone else?
Um, Population of Bahamian decrease because there'll be more Haitians mixing with Bahamians. I don't know if that makes
Okay.
sense.
Okay. Population will decrease.
I I was thinking that
Uh.
it would be easier like to support multiple names and like cause a lot of like falsify everything then. So I didn't think
I don't understand what you're saying.
yeah
What
you
you?
could it'd be easier to okay it would be easier like to falsify like some documents and stuff.
Why? Why, Nancy?
And you said that if the government don't control immigration,
Uh-huh.
that's what you asked about.
Yes.
I was saying that you don't control it. That means he's not checking or anything and stuff like so there will be
Oh.
updates or like
Oh,
basically
okay.
they can do whatever. So
Okay.
I was
Oh, you
thinking
go on that? Oh, you
what's
go
the
on that
why
extent?
would I pay 6 or 7 passports into
Mr. Petit.
Uh-huh.
Are you on the word connect to go?
Connect should go. It's but the conclusion. But okay. But the conclusion. But the conclusion requires. But the conclusion requires a greater leap in logic to connect the premise to the conclusion. To connect the premise to the conclusion.
Oh, the immigrants like I don't know take up like oh I just had it in my head
Mm-hmm.
like jobs and
Mm-hmm.
and medical treatment and schooling and stuff
Mm-hmm.
like it'll be
Mm-hmm.
I trying to full word and
Mm-hmm.
it'll just take over like
They'll
take
take
up
over.
the spaces of
Uh.
yeah.
Uh. Okay. Okay. I like the answers y'all giving. Y'all, I love the answers y'all giving. And I can tell, I explain to you why I love the answers you give. Anyone else?
Sit down with the example.
Yeah, another example.
another example could be that
I see the example.
No, what I'm
they
saying.
could you could smuggle in criminals and stuff under different.
Okay, so listen to this one. This is a this is this is a someone giving a feedback on what would be the consequence of if the government doesn't put no effective control on immigration. It says if the government puts no effective immigration control in place, the country will continue to see increasing numbers of illegal residents who will in time outnumber Bahamians Our official language will be Haitian Creole, and Bahamians will be new refugees in the United States. All right. So that's this person's view at this, right? Now, the thing is, this is a slippery slope, right? And almost all of your comments were slippery slope. What I mean is that you gotta be careful in your writing not to make great leaps, right? Like for example, this person is saying just because the government does not put any control on immigration, that our official language will be Haitian Creole. Like, how does that? How will that happen? Right? Like, will it really become that bad that the official language will change? Like, think about it. And then it says refugees. The Bahamians will become new refugees in the United States. Right? Will it really become that bad? Like, it seems as if this person is jumping too far. Right? Um, and other persons, and some of you said it, some person said it, it's going to be chaos, and um it's going to be, you know some person was saying, the immigrants are going to take all the resources, they're going to take all the jobs, they're going to take. And that's the natural rhetoric of the newspapers and the media, that the immigrants are going to take all the jobs, and they're going to take all the medical care and all the education. They are examples of slippery slope fallacy, right? We have to be very careful. We have to be realistic. Like, what actually happens? What is the real reason why? Um, what is the real reason why um, there's less jobs for people? What's the real reason why um, the healthcare system is failing? Is it really because of the immigrants, or is it because of more deeper issues, right? For example, if a let's say for example, if an immigrant from Cuba, fresh from Cuba, come to the Bahamas, right? um whose job will he really take, right? Will he take the banker's job, who working from 9 to 5, or will he take the job of a yardman person? Like, he just come from Cuba, fresh from Cuba, has no documents. How in the world will he get an office job? How in the world will he get a job in a very high
He'll be
place?
in the yard.
He'll be in the yard. So when we say that immigrants are gonna come and take all the jobs from the Bahamians, the question is, which jobs are they taking? They fresh from the boat. Like, who job they really taking? Like, who jobs they could really take? Are they taking the jobs from those people who are qualified, or are they taking the jobs from people who are unqualified? Let's say, for example, as simple as being a teacher, as simple as being a police officer, as simple as being a defense force officer, as simple as being, what's another one? As simple as being a dentist, as simple as being the doctor, right? When these immigrants come fresh from the boat with no documents, you really think they take in the lawyer's place? You really think they take in the doctor's place? Like, whose jobs are they really taking, right? So, um, so sometimes when we um give our arguments, we jump too far, and that's all slippery slope is saying. Slippery slope is saying you want to be careful how far you jump, right? You don't want to jump so far that you end up not really making a lot of sense, right? When you begin to speak. Right? So I don't hear from you. Do you agree with my statements? Do you disagree? What are you saying?
I agree.
You agree? Anyone else?
I agree with you, but like
But
it's like yeah, but
go ahead.
I do agree with you now. Like if they just come, they won't get like the high earning job.
Yes.
But like okay, just gonna use me for an example. I have nothing against immigrants. Let me just
Yeah, go ahead.
use me for example. When I used to go to junior school, right?
Uh huh.
Um, they couldn't find a class to put me in. They couldn't find class to put me in because the class was full. And when I was sitting on the side until they find class to put me, in, it was like the students that were speaking Creole. I was new, and it was like a bunch of them. All of them was speaking Creole. It was like when I say like over the year, I sound horrible when I say over the year. Like those same students in school could become doctors and bankers and stuff and leaders and stuff. So eventually they could take over.
But okay, let's be.
So some like some
Go ahead.
some immigrant students, they like their parents is pushing them in education,
Yeah.
like hard in education.
Yeah.
So they be the top students.
Yes.
So if the future not okay, the present immigrants that just come, they not them, but their offsprings
Yeah.
can take over the
Okay.
Bahamas.
So take home. Okay. Again. All right. Again. All right. Say take over. Say take over. I want I want Miss Rackley to understand something. Um, remember that let's take a look at America, for example, right? Um, do you think America um is built only by Americans? Like, you think that the only persons who are in leadership roles in America are only Americans?
No, sir.
Exactly, right?
No, sir.
You have people, you have Chinese over there, you have Indians over there, you have a lot of Cubans over there, right? The fact is that a country becomes great because of diversity. So just because an immigrant comes and they have offspring and their offspring end up being successful, um, that's more beneficial for the country itself, because at the end of the day, whatever role that they take, they will be they will be serving the country. You understand what I'm saying? So it would be good if we could get more qualified people to come and work, right? And that's what America do. America take the smartest people from China, the smartest people from Australia, the smartest people from England, the smartest people from Africa, and guess where they go work? They go work right in America, and America don't have no problem with that, right? But it's something about the Bahamas and something about the Caribbean islands I don't understand. Um, that they have an issue with other immigrants coming over and taking responsible positions. It's no real issue because um, that's how that's how the true nations really do it. They take the best from everywhere to make their country great, because they understand that um, not only Americans could build America, and not only Bahamians could build the Bahamas. It takes a collective effort. You understand where I come from? I don't know if you ever was one of the students who you was in a government school, but then a private school um come and take you to join their school. Anyone know people like that?
That is me.
That's you?
Yeah, my cousin.
That's
Okay.
me.
Okay.
That's me.
Okay.
That's me. That's me.
Okay, good.
I was mid school and then I transferred.
Okay, good. See, that's the thing. Why do you think the private school is gonna take you? The private school looking at skill and ability, right? And so it's the same thing, right? Um, it's the same thing, right? Um, we looking at skill and ability, all right, and not necessarily nationality, all right.
Yeah, I can understand like getting people with skills, but these just like
Uh-huh.
if you never know they could be like criminals.
Okay, that's that, and that's what we don't want. We want to have effective immigration such that
Let me let me my bad.
we want to have effective immigration such that um the persons who come in the right way, right? And the right people come in the right way. Right? I don't see nothing wrong with that. Um, but having people who don't speak like you and who don't look like you in your country is not necessarily a bad thing, especially if they know what they're doing. Um, and so that's the thing. But and that's the thing. That's what I'm saying. My point is, it wouldn't necessarily lead to chaos, right? Um, just because you have persons who are not Bahamians in your country, and it doesn't mean that your country will change into speaking Creole or change to speaking Chinese or whatever. Take a look at America. The national language for America is still English. You know how much Chinese in America? You know how much French people in America? You know how much Indians in America, Cubans in America? Yet their official language is still English, right? So it won't turn for the worse as much as people think, right? And so that's the example of slippery slope, where we over exaggerate too much, right? And it leads us into too much, and it leads us into a lot of problems when we push the issue too much, you know. So that's one thing. So we have to be careful with that. All right. So the next thing is, um, the next thing kind of fallacies that we want to talk about is the false fallacies. Yeah, I know I stopped sharing. Okay, I put it in the chat because I having a problem with my internet.
Okay, my bad.
Yeah, so the false fallacy. Now, the false fallacy, the first one you're going to talk about is false authority. False authority. That's the first one under false fallacies. False authority. You one thing, they have an idea of what that might mean? False authority.
Okay, you meant okay, like you stating your bias reason towards a situation, but you don't have like the ability to like a question.
No. Authority. Who's an authority?
I have a guess.
Go ahead.
Someone in power.
Yeah, someone in power. Go ahead, go ahead, Michaela.
It's like you have.
I didn't hear that.
It means like saying like your opinion as if it's someone who's in power's opinion.
That's close. That's close, but that's not
I
quite
think
it.
it's like um I have to actually. I think it's either maybe like pretending that I think like you don't have the right you like false rights, like you don't have the right to say this. I don't know.
No. It's okay.
Like, would it be like saying something like demanding something, but you're not like in a position of power to make that demands?
Very close. Very close. Very close. Okay, so
Yeah,
yeah, you're very
answering
close.
that.
No. So what if, right? Okay, what if I say? What if I say that okay, what if I say that, all right, the prime minister now is Philip Brave Davis, right? Minister Philip Brave Davis, right? What if I say that that um smoking is good for your health? And he says, well, how do you know that? Well, I say, because the prime minister Philip Brave Davis said that. um would that be right?
No.
No. Why would that be right? Why wouldn't that be right?
Because he like you know.
Say it again.
Cause like the spot he in now, like he earned that or like he went.
No. Why can't I use Philip Brave Davis when it comes to now he's the prime minister, but when it comes to health issues, can I use him as authority?
No, sir.
No.
He can sign a sign. He can sign everything to that
Exactly.
help.
Exactly. So just because he's the prime minister, um, I cannot use him as proof or evidence if I want to say something about health. Who must I use if I want to say something about health? Who must I use? Someone who's a what?
Field health, doctors.
Yeah. Someone who is a someone who's a doctor, exactly. So just because the person is a prime minister, I can't use them to support everything, right? If there's a prime minister, I could use them to talk about things about politics. Yeah, I could do that. But if they are a prime minister, I can't use them to talk about things about health. I can't use them to talk about things about religion, right? Because they're the prime minister. Their expertise is with governing the country, right? And so we want to be careful with trying to back up what we say, using someone who, even though they have authority, they don't have expertise or they don't have knowledge in that particular area. Like, say, for example, my teacher said that drinking um, colic is good for eczema. Now, is that a good thing, right? Is that a is that a can we use our teacher um to back up that statement?
No, sir.
No, right? So we can't say that.
Because not a dermatologist.
Exactly, exactly. Say it again, right? So
I say no because he's not a dermatologist.
very good, very.
Teacher.
Exactly, she's a teacher, right? And so we cannot use her, right? And when you're in school, you think that the teacher's right about everything. But let me tell you the honest truth: the teachers are not right about everything, right? You need an expert in the field to tell you. Okay. What's it? Give me another example.
I never thought that.
Oh, okay, okay. So I never probably when he was younger, like in primary school. Mommy, teacher say 2 plus 2 is 5. 2 plus 2 is 5.
No, even in primary school, I knew like something they say was true.
Oh, okay, okay, okay. All right. Don't go tell the teacher that. Nah, you might get the merit. All right. Okay, give me another example. Go ahead, give me another example. Anyone?
Um, I mean, the doctor said that um, we need health cards in order to pass the Bgcse.
Okay. All right, I can understand. He may not be as a doctor, you may not know about the exam, so I understand what you're talking about. Um, something better than that though. I thought you was gonna say as a doctor, you could say that you could say that what they call that, man, brake fluid. Brake fluid is good to clean your tires with because my doctor said so. Is that
Could this be one? My dad said take 5 Panadol to clear my head.
to what? To what? To do what?
My dad said to take 5 Panadol tablets to get rid of my headache.
Oh, okay. Good one.
You can get that kind of good with all of them pills. Gee.
All right. I like this one. This is an example that I have here. It says, as president of a top security company, he blames. No, so no. Let me read it properly. As president of a top security company, he blames the weakened family structure for rise in crime. So the key to reducing crime is to strengthen the family unit. What is that an example of, and why is so?
He's a security president of a security company.
Okay.
He takes care of security.
Exactly.
Like, like how we get in that? Like,
So
I feel as if I know a lot of people like this.
yeah.
What he can put camera in everybody's face.
Yeah. I mean, the security officer has a good point. The key to reducing the key to crime is, strengthening the family structure. That's a good thing, right? But the problem with this is that you're using him as your foundation, right? So even though this is a good point that was raised, it ended up being a bad point because you start talking about the security officer, right? In academics, when you're writing academically, we do not care how much president use this, president that. You need to be an expert in the field. Then we could use you. You know what I'm saying? The same thing with Bill Gates. Bill Gates, sorry, let me not get into that controversy. um, but you get what I'm saying? Um, he's the president of a security company, so he we cannot use him as a source when talking about the family and family structure and um and and the problem with rise and crime. We can't use him. We have to use someone more better. Someone say like maybe the commissioner of police would be a better one, or maybe a psychiatrist, or maybe a counselor, or maybe some people like them, who have related experiences and stuff like that. All right, so that's the issue right there. Okay. All right. So with that, I'm gonna end. I'm not gonna continue any longer. So we're just gonna end with false authority. So tonight all we did was slippery slope and false authority. We're gonna continue with our false fallacies. When we come back on Monday. Oh, I love to give an announcement on Thursday. I'll see. Because I'm wondering if I wanna continue for next week. I'm not sure yet. But we'll see. Um, so tomorrow at 6 o'clock. Um, for our last class for the week. Thank you all so much for enduring, even with the hiccups that we had. Thank you for sticking through. And I'll see you, God spare, on
Later.
yes, ma'am, on tomorrow. Take care.
Goodbye.
I thought you were gonna say that's the last class of the month.
It might be. It might be. We'll see. I'll have to make the announcement tomorrow. I ain't sure yet.
We'll have a class party.
Say a class party. Say a class party.
From virtual class party.
I don't know what was directly thinking about. Directly probably thinking about a live. We could have one. All I need to do is all I need to do is get a picture. Put it on the screen. Put it on the screen. I'll let y'all watch a video. I'll let y'all watch a video of people eating pizza. All right. Have a wonderful night. Good night. Good night. Good night.